Every railway line on Earth runs over the same strange detail. Not the rails, not the wooden or concrete beams beneath them, the stones. Thousands of grey, sharp-edged rocks spread out for miles, under every train that has ever passed. You've probably stood at a platform and looked straight down at them without a second thought. But those stones are doing a job so critical that without them, the entire railway system as we know it would fail within weeks. Stick around, because by the end of this, you'll never see a train track the same way again. And if hidden engineering like this fascinates you, this channel unpacks one everyday mystery like it every single week. So consider subscribing before we get into it. Here's what most people never consider. A fully loaded train can weigh several hundred tons, and all of that weight travels on a strip of steel barely a few centimeters wide. Every time a train passes, that force doesn't just sit there. It pounds into the ground below, over and over, thousands of times a day. Now add rain, frost, heat, and shifting soil underneath. Solid ground alone can't handle that kind of repeated, concentrated punishment. It compresses unevenly, it shifts. Left alone, the track bed would slowly warp, sink in some places, and rise in others. And a warped track at high speed is a disaster waiting to happen. Engineers needed something between the rails and the earth that could absorb, spread out, and survive that punishment indefinitely. That's the real problem those stones were built to solve. The stones have an actual name, ballast. And they're not just poured on randomly, they're chosen and shaped with intent. Real railway ballast is crushed, angular rock, not smooth river stones. That jagged shape matters enormously. When crushed stones interlock with each other, they lock the track in place far better than smooth, rounded pebbles ever could. Underneath the rails sits a layer of these interlocking stones, usually 25 to 30 centimeters deep, resting on more layers of graded material below. When a train rolls over, the immense weight doesn't slam directly into soft earth. It spreads out sideways and downward through the stone layer, like pressure dispersing through a net instead of hitting one single point. By the time that force reaches the natural ground underneath, it's a fraction of what it started as. The stones essentially act as a shock absorber and a weight distribution system working together, silently, under every single train that passes. Here's where it gets more clever. That same layer of stones is quietly solving 3 or 4 other problems at once. First, drainage. Gaps between the angular stones let rainwater fall straight through instead of pooling on the track bed, which would otherwise turn to mud and destabilize everything above it. Second, vegetation. Weeds and grass struggle to root in loose, shifting rock, which keeps plant growth from cracking the structure underneath over time. Third, thermal movement. Steel rails expand in heat and contract in cold, and the loose stone bed gives the whole structure just enough flexibility to handle that expansion without buckling. And fourth, something most riders never notice. The stones dampen vibration and sound, absorbing some of the noise and rattle a train would otherwise send straight into the surrounding ground. One material, 4 separate engineering jobs. That's not an accident. That's decades of trial and error, compressed into a design so simple, most people assume it's just gravel. Here's a detail almost nobody knows. Engineers don't just call this layer stones, they call it ballast. And that word didn't start on land at all. It started on the ocean, centuries before a single railway existed. Old sailing ships, when empty of cargo, rode dangerously high and unstable in the water. To keep them balanced, crews loaded the hull with heavy rock before setting sail, weight that had no purpose except to keep the ship steady. That rock was called ballast. When railways emerged generations later, engineers facing their own stability problem needed the exact same thing: dense, heavy material with no job except to hold something steady against constant motion. They reached for a word the shipping world had already been using for hundreds of years: because the function was identical, just moved from water to land. It's a small detail, but it means every train you've ever ridden is quietly carrying a term invented for keeping wooden ships from capsizing. So the next time you're standing on a platform, waiting for a train, take a second look at the ground beneath the rails. Those stones aren't filler, and they were never random. They're a weight distribution system, a drainage system, a temperature buffer, and a sound dampener, carrying a name borrowed from the bottom of old ships' hulls. It's one of those details engineered so well that its entire job is to be ignored. If you enjoyed uncovering the hidden logic behind something this ordinary, hit like and subscribe. There's a whole world of everyday objects hiding engineering just like this, and we'll keep uncovering them, one video at a time.